Next, I'm going to talk about one model to illustrate some of these ideas. And this is the model. It's one of the simplest model in machine learning, but doesn't mean that it's not powerful. In fact, in many cases, nearest neighbor is still a very useful, very powerful model for many applications here. So nearest model here is also a model here. There's no parameters. That's very interesting models here. You don't need to learn parameters within the models. So that's kind of very special for the nearest neighbor approaches here. All right, let me explain what is nearest neighbor here. So suppose we want to solve a regression problem. So as I mentioned here, regression is this, right? Input, you have X here, and you want to predict Y. Y is going if it's a regression, Y is going to be a continuous number, right? It's a continuous number. That's called a regression problem. And in this diagram here, I have this one-dimensional regression problem. I have X here, the feature. I only have one feature here, and this is Y here. And the red dots represent the data in the training samples I have here. Right. So I have multiple training samples here. And then I want to build a predictive models. And they essentially say, suppose I have new data sets here. So new data is here. This is my new. And I want to predict the values at this X new here. Where should I put it here? Should I put it here? Should I put it here? Where should I put, right? And that's the regression problem, right? So in the nearest neighbor approaches here is this. So taking very simple approaches here. Essentially now, give me a new X here. What I'm gonna do here, I'm gonna find the training data, find the X here that is closest to this X new, the nearest to this X new here. So if you look among all the here, along the x-axis here, which one is closest to X new? Well, you can see that immediately here, this red dot, right, is closest to X new here. So I just want to make sure that when we evaluate this closeness is only along this x-axis here, because this y-axis is prediction. So that's just make sure to understand that. So of course, along the axis here, this is closest here. And then once I identify the closest datum in the training sets, and I'm going to assign the y labels here, assign its y label to be the predicted values of this X new. So which means that what y should I predict? Well, I'm going to predict to be exactly the values of this ones here, this values here. That would be roughly 20 something here, this value of this guys here. So that is called a nearest neighbor regression. Then this is the nearest neighbor of this data sets here, right? So as a result of that, I would generate the predicted functions, predicted values of all data along this x-axis here. And they will look something like this, look something like a piecewise constant function. So why it is a piecewise constant function is because now suppose I have an example here, this is my X new here, and this is corresponding nearest neighbor. But now I'm gonna say, I'm gonna walk away from this neighbor here, walk away here. You know, within certain distance of that, its nearest neighbor is still going to be this point here, right? Only after certain distance, its nearest neighbor jump from this one to the other ones here, right? So, and this point here is a point located in between, right in the middle between this data and this data here. And only at this point here, you will see that its predicted value switches from the value associated with this data sample to the value associated with this data samples here. And now if we move away here, so now all the prediction is associated with its nearest neighbor. So now if I move away, now, oh, it switched to another neighbor here. And that is the y value associated with this one here. So as you can see, you know, the predicted function based on nearest neighbor will have this type of a shape here. It will be piecewise constant functions of that. It's very simple, and I simply identify its closest neighbors and assign the neighbor's y to be its y, to be its predicted values of that. That's called a nearest neighbor regression.